What if I told you that a small dim object slipping through our solar system could expose the biggest mistake of modern astronomy, not because we lacked good instruments, 50, but because we were too confident in our assumptions. Imagine you and I standing together on a crisp fall night in, say, northern Arizona. The Milky Way is a pale river overhead. We feel in our bones that the universe is large, ancient, indifferent. And yet we also feel something else, that it is knowable. We point telescopes at the sky and expect nature to play by rules we already wrote down in textbooks. Now consider this an interstellar visitor called 3I, it's ATLAS, 3I, meaning the third confirmed object to come from another, has been doing things that don't sit comfortably inside our tiny categories. It is not just moving across the sky. It is teaching us a lesson about how science works when reality refuses to cooperate. The question I want to explore with you today is not TI's 3LS TS alien technology. The question is more basic and more profound. 50. How did we misjudge it so badly? And what does that say about us? Because in my experience, the biggest discoveries don't start with answers. They start with discomfort. I care about this topic for a personal reason. I have been studying interstellar objects for years. Ever since the first one, Oumuamua, surprised us in 2017. When that object appeared, it felt like a knock on the door of the solar system. Most of my colleagues treated it as a curiosity, an icy shard thrown off some distant comet. I looked at the data and felt uneasy. Its shape, its brightness variations, its acceleration away from the sun without a visible cometary tail, none of that fit neatly. Back then, I said something simple. We should not assume nature when we don't have evidence. We should follow the numbers wherever they lead. That position was labeled controversial, not because it violated scientific method, but because it violated scientific culture. And now with 3 alias, that tension returns, only louder. As a scientist, as a father, and simply as a human being who has spent nights thinking about our place in the cosmos, 50, I can't look away. Let me walk you through what makes 3 alias so unsettling, and why the story matters to you, even if you've never peered through a telescope. When 3 alias was first detected, it looked like a comet at a distance, faint, fast. The object on a hyperbolic trajectory that told us it wasn't bound to the sun. 50. Initial reports fit the familiar script. Another interstellar wonder, probably an icy body. Passive. Leftover rubble from planet formation around another star. We have a comfortable mental shelf for that category. We label, we store, we move on. But the minute we began tracking its motion precisely, the shelf started to wobble. Its deceleration didn't match what gravity alone would predict. Now, deceleration itself is not exotic. The comets vent gas as they warm, and like a leaky balloon, they get a small push. In physics, we call this non-gravitational acceleration. It's common. What was not common here was the pattern and magnitude. The force seemed too orderly, too sustained. In a direction that didn't align with the simplest outgassing models. 50, I'll never forget an afternoon in my office at Harvard years ago, and when a graduate student walked in holding a printout of Oumuamua's trajectory. She was bright, skeptical, careful. 50, she pointed to the residuals, the tiny differences between predicted and observed positions, and said, Professor, if this were a comet, we'd see a tail, we see nothing. That was a quiet moment, not dramatic, no Hollywood music, just a scientist noticing that the universe had not read our paper. With 3 TLS, I had a similar moment, only it arrived as a phone call at an inconvenient hour. A colleague said, Avi, the orbital fit is getting worse the more data we add. That is the opposite of what you want. More observations should tighten your model, not unravel it. It was like building a bridge where each new bolt makes the structure less stable. 15, nature doesn't behave like that unless we're missing something essential. Then the imaging came in. Higher resolution infrared and optical data suggested that this object may not be a solid monolith. 50, there were hints of a hollow interior, or at least a very low bulk density, like a cosmic tumbleweed. Again, a hollow object is not impossible in nature. We have porous asteroids. We have rubble piles. But the geometry implied something more structured than a random heap. Think about it this way. 50, if you find a piece of driftwood on a beach, you assume the ocean shaped it. If you find a wooden canoe with clean ribs and a sealed hole, you don't say, yes, waves did that. You infer design because the shape carries intention. The hard part is admitting when you are looking at a canoe. Now, at this point, 50, what a reasonable person might say, Avi, you're getting ahead of yourself. Strange comets exist. The exotic ices exist. We should prefer a natural explanation. I agree with the principle. 50, the simplest explanation consistent with the evidence should be our default. But only if it is consistent with the evidence. We do not get to declare simplicity by ignoring inconvenient facts. 50, the most startling facts arrived with spectroscopy, our way of fingerprinting materials, by how they absorb and emit light. 50, the expectation was clear water, ice, carbon dioxide, carbon monoxide, dust. That's what comets are made of. The early spectral lines did show some familiar volatiles. But the dominant features, especially in the mid-infrared, did not match anything in our databases. Now, I spend much of my life thinking about how matter behaves under strange conditions. The universe has no obligation to contain only substances we already cataloged. So the first reaction is humility. Perhaps this is chemistry from different stellar nursery, a compound that forms rarely or only in deep interstellar cold. That would would be thrilling enough. And yet the distribution of these spectral features was not uniform. The different regions of the surface had sharply separated compositions. There were boundaries that appeared straight over large distances. Nature can make straight lines. Crystal faces do that, but not on scales of hundreds of meters without a guiding process. Geological activity can make patterns too, but 3 is not a planet with tectonics. It is a small body called traveling the void. Here is where I want to slow down and share another story moment. Years ago, I visited the Giza Plateau in Egypt. I remember walking around the pyramids at sunrise. You can feel the desert wind. You can see sand accumulating over millennia. Erosion has softened edges. But the underlying geometry still announces itself. The structure resists randomness because it was built with purpose. 50. When I saw the surface maps of 3 I felt a faint echo of that sensation. Geometry surviving and surviving where pure chance should have smeared it away. Then there were the apertures. The circular openings, remarkably round, on the order of a few hundred meters across. Picture a football stadium nearly 1,000 feet in diameter, not one, but several, arranged in a symmetric pattern. Again, I am not saying nature cannot carve holes. Impacts can do that. Sublimation can do that, but impacts don't coordinate into hexagons. Sublimation doesn't punch perfect circles of similar size at regular spacing. 50, we can calculate probabilities for accidental symmetry, and the numbers are not kind to coincidence. The question becomes, if not random geology, then what? And here I want to be honest with you about how a scientist should feel. 50, we should feel two emotions at once. One is skepticism and do not jump to conclusions. The other is curiosity, do not run away from anomalies. 50, the job is to live in that tension without collapsing into denial or fantasy. The most controversial data point, and the one that captured public imagination. 50 is the electromagnetic signal associated with the object. 50. Several observatories detected coherent low frequency emission in the kilohertz range. To most people, that's an obscure detail. Let me translate it. The kilohertz band. The kilohertz band is the part of the radio spectrum that can travel through plasma and dust with relatively low absorption. Submarines on Earth use low frequencies because they penetrate seawater. If you wanted to send a signal through the interstellar medium and not have it drowned out, the Prevent 50, you might choose something similar. The signal's power level was substantial, 50, and it appeared modulated with a period matching the object's rotation, t. If this holds up under further analysis, it means the emission is tied to the object structure, t, not to some random background source. Nature has radio sources, of course. The pulsars and magnetars are the lighthouses of the galaxy, but their emissions are linked to neutron stars, to magnetic catastrophes, to environments far more extreme than a small interstellar body. Here we have a modest sized object producing a stable, organized field. That is what raises eyebrows. At this stage, the conservative path is to search for natural engines, 50 perhaps unusual magnetic minerals interacting with the solar wind, perhaps a plasma sheath, perhaps some chemical cycle that creates periodic discharge. The scientists have invented such explanations before. Sometimes they are right. Sometimes they are elaborate castles built to avoid saying I don't know. What makes 3ID ATLAS especially intriguing is that the emission appeared to change when we focused our best instruments on it. The modulation shifted into packet-like bursts as if something altered its broadcast behavior. Now, 50 correlation is not collation. I want that on the table, but the timing forces a question. What natural process notices scrutiny? The only domain where observation changes behavior is quantum mechanics. And quantum effects do not normally govern macroscopic structures unless a technology is engineered to amplify them. I can almost hear you thinking, Avi, this is starting to sound like science fiction. And so, let me say this plainly. The science fiction is a genre of imagination without evidence. Science is imagination disciplined by evidence. The difference is not in the strangeness of the ideas, but in the honesty with the data. So where did we miscalculate? I believe the biggest miscalculation was psychological. We treated 3ATLAS as a member of a known family before we checked its ID. We saw interstellar object and assumed interstellar rock. That's like seeing a visitor arrive at an airport and assuming they are a tourist. Maybe they are a diplomat, maybe they are an archaeologist. The label you choose determines the questions you ask. If you ask the wrong questions, you miss the truth. This pattern is not new. In the history of science, the establishment often clings to comfortable interpretations longer than the evidence deserves. When Galileo pointed his telescope at Jupiter and saw moons orbiting another planet, the simplest model of the cosmos collapsed. But many refused to look through his lens because the implication was heresy. When continental drift was proposed, geologists mocked it for decades because they lacked a mechanism. The continents did not care about mockery. They moved anyway. We have been trained subtly, culturally, to treat the possibility of extraterrestrial technology as taboo. Not because it is unscientific, but because it feels destabilizing. It threatens our sense of uniqueness. It threatens academic reputations. It threatens funding pathways that reward safe incremental work. And so the reflex is to say, it must be natural, even when natural requires a chain of unlikely coincidences. Maybe even 50. I'm not arguing for abandoning skepticism. I'm arguing for applying skepticism evenly. If you are willing to entertain an exotic natural explanation that violates multiple expectations, you should be at least willing to entertain the possibility of design. Both are extraordinary. T. The only difference is emotional comfort. Let me show you why this matters to Americans sitting at home, T, paying rent, worrying about their kids' future, T, maybe feeling that cosmic debates are distant from daily life. If 3x at LIS is natural, T, it still teaches us that our models of small bodies, of interstellar chemistry, T, of comet physics are incomplete. That affects planetary defense, resource scouting, T, and how we interpret future visitors, T. If it is artificial, or even if there is a non-zero chance is artificial, then this is the first evidence that intelligence exists elsewhere and that it can traverse between stars. That changes the story of humanity. It changes the long-term priorities of civilization. It asks us to mature. You might say, why would an alien artifact come here? I don't know. But I can make a humble comparison. When we send spacecraft to Mars or to the outer planets, we often do it not to make contact, but to explore, to map, to learn. Sometimes we leave landers as silent witnesses. It doesn't mean hostility. It means curiosity. 50. If another civilization is more advanced than ours, they might view our solar system the way we view a coral reef, interesting, maybe inhabited, worth a look from a distance. And notice the key philosophical shift. The story is no longer about whether we are special. The story becomes about whether we are paying attention. A visitor could pass through and we might not recognize it for what it is, just as isolated tribes once saw ships on the horizon and folded them into myths because the concept of engineered vessels didn't exist in their worldview. What comes next? In the near term, we must gather more data. That sounds obvious, but it is the hardest part. Data require time on telescopes, and time requires money, and money requires conviction. The scientific community is like a big ship. It takes effort to turn. We need coordinated observation campaigns across wavelengths, radio, infrared, optical, and ideally, we would send a spacecraft to intercept such an object in the future, not to greet it with flags, but to measure it directly in 10 years. If we take this seriously, we could have a network of dedicated sky surveys tuned to catch interstellar objects early. We could dispatch rapid probes like cosmic field biologists to sample them. In 50 years, we might look back at 3i ATL as the way we look back at the first microscope, a crude beginning that opened unseen world. And in 100 years, if the universe is populated by other technological civilizations, and then interstellar archaeology could become a discipline as real as marine biology. We might catalog relics, probes, perhaps even derelict ships, some dead, some active, drifting between stars. The night sky would no longer be just a view. It would be a neighborhood. There is a kind of wonder in that possibility, but also a responsibility. If we are not alone, then our actions represent Earth to a much larger community of minds. And then 50, the way we treat each other, the way we treat our planet, the way we handle knowledge, those are not parochial issues, they are cosmic. Let me end where I began, under that dark Arizona sky. When you look up, you see light that even left its stars before humans built cities, before we wrote constitutions, before we knew what electricity was. The universe has been running a long time without asking our permission. Every so often, it sends a surprise that nudges our perspective. 3 Ike ATLS may be such a nudge, maybe be in the end, we will find a natural explanation that is elegant and new. If so, wonderful. Science will grow. Maybe we will find evidence of technology, of design, of another intelligence. If so, also wonderful, though it will require courage. Either way, fifth stellar fictive, the real miscalculation was thinking we already knew the range of possibilities. The cosmos is not obliged to fit into our filing cabinet. Our job is to keep a cabinet flexible, to keep curiosity alive, to admit when we are wrong, and to be brave enough to learn. So I leave you with a question that is both scientific and personal. When the universe offers a clue that we are not the center of the story, do we look harder or do we look away? I hope we look harder, because the greatest privilege of being human is not certainty. It is the chance to discover.